Okay, very few more topics we have to cover the syllabus, complete the syllabus. Today we can see them. Okay. Today itself I complete our syllabus, full syllabus, so that you can ask your doubts tomorrow class. After that you will be ready to write the exam. Your exam is on 25th, you know. You got the timetable? For discrete
Yes, ma'am.
mathematics exam is on 25th, Wednesday, next Wednesday. 8 more days you have to study. You please study well. Last two units, the fourth and fifth unit are the syllabus for your cycle test. When I taught you handshaking theorem, I told you it's for both directed and undirected graph. When we have undirected graph, I told you that sum of degree of all vertices equal to 2 times of number of edges. It's for undirected graph. When we have a directed graph, the same degree we are finding in two ways. One is in degree, another one is out degree. So that the same handshaking theorem, when we define it for directed graph, the statement it comes like that. For all I, degree of V minus Vi plus for all j, degree of I also can write plus Vi equal to 2 times of V. So the in degree plus out degree equal to 2 times of V. Otherwise you can write like this also, summation overall I in degree of Vi equal to summation overall I degree plus out degree of Vi equal to E. You can define the handshaking theorem in two ways for directed graph. You understood these two concepts? You understood these two concepts? Now we are going to do some problems based on the handshaking theorem for directed graph. Undirected graph means you can verify it easily. Okay, when you have a directed graph, how can we check the handshaking theorem? Specifically, it is given in our syllabus so that we can do some problems. Okay. Shall I rub the board now? Hello. Have you noted the statement? Handshaking theorem. First one is for undirected graph. These two for directed graph. Have you noted the statement? Hello? Hello? Shall I rub the board now? One of you reply. Hello? Samar? Samar Patel. Hello?
Yes, ma'am.
Sandesh. Shall I rub the board?
Yes, ma'am.
Now you write down a question. Verify handshaking theorem for the following diagram. Verify handshaking theorem for the following diagrams. First problem. second graph. That's it. For these two graphs, we have to verify handshaking theorem. One problem I do, remaining one you do yourself. Which one I can do it now? Hello? Which one? First or second problem? Can I do the second one? Hello? Hello? Ajay?
Yes,
Ayush? Can you do the second problem now?
yes, ma'am.
Okay. Actually, we have to verify the handshaking theorem for the given graph. We can denote it by G. By handshaking theorem, summation overall I degree minus vi equal to summation overall I degree plus out degree equal to E. E where E is the number of edges in the graph. Where E is the number of edges in the graph. For that, we have to write all in degree and out degree of each and every vertex. Okay. We can start with A. Degree, in degree, degree minus of A. Degree plus of A. Degree minus B. Degree plus B. Degree minus C. Degree plus C. Degree minus D. Degree plus D. See, one more vertex we have for that. Now you tell me in degree, out degree of all vertices. Can you tell me yourself? What is the in degree of A? In degree of A means the number of edges converges at A. So this loop includes both in degree as well as out degree. For in degree 1, 2, there are 2 edges converges at A. But 1, 2, 3, 4 edges emanate from A. So out degree of A is 4, in degree of A is 2. Likewise, can you tell me the remaining what is in degree, out degree? Can you tell me yourself? Hardik Sharma? Hardik? Can you tell me? In degree of B? In degree of B? 1, 2, 3. Can you identify? That is 3. Out degree of B? Only 1. This is that one. Degree minus of C? Loop, we have to count it in both the out degree as well as in degree. So 1, 2. This is 2. Out degree of C is again 2. See here, 1 loop, 2. Degree minus of D, degree minus in degree of D, 1. Out degree of D, that is 2. In degree of E, 2. Out degree, only 1. Okay, here we denote one more vertex F. Degree minus of F is 0. Degree plus of F is also 0. Why? Because there is no edge incident with that vertex F. Okay, now by means of this handshaking theorem, minus all in degree sum 2, 3, 5, 5 plus 2, 7, 7 plus 1. Which one? E is degree. What is in degree of E? 1, 2, okay, totally 10. 2, 2 plus 3, 5, 5 plus 2, 7, 7 plus 1, 8, 8 plus 2, 10, 10 plus 0, 10. So this answer is 10. What happens in out degree? 4, 4 plus 1, 5, 5 plus 2, 7, 7 plus 2, 9, 9 plus 1, 10. How many edges we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, handshaking theorem is verified for the directed law. You understood this concept? Can you do like this in the first problem yourself? Hello? Hello? Can you go to the next concept?
Yes, ma'am.
Okay, next is graph coloring. What it is the coloring of graph? I rub the board now. Next concept, graph coloring. A coloring of a simple graph is the assignment of a color to each vertex of the graph. So they assign the same color. Likewise, we have to assign colors. For example, we have a graph like this. We have to color the vertices. The only condition, no two adjacent vertices can color by the same color. Likewise, I can start with red. If I mark red to this vertex, I cannot use this red to these two vertices, but I can use red to this vertex. Why? Because these two are not directly connected. Okay, they are not adjacent. For this, I can color another color, green, so that I can use the same color. Here it is. You can ask me, why ma'am we can color like this, red, blue, green, yellow, likewise also we can color. No? That difference, we study it in chromatic number. This is also graph coloring. This is also graph coloring. What it is the chromatic number means the minimum number of different colors used to color the vertices of a graph is known as chromatic number. If we use different colors means all are different only. Then what it is the use to study? We have to minimize the different colors to color vertices. That minimum number is known as chromatic number. You understood graph coloring? And one more theorem which is very important. This theorem statement only in our syllabus. No need to study its proof. That is known as four color theorem. Four-color theorem. Four-color theorem means the chromatic number of a planar graph. The chromatic number of a planar graph is no greater than greater than 4. That is known as four-color theorem. You should know what it is planar graph. Graph, digraph, connected graph, everything you studied already. The planar graph is different. I explained you. A graph is called planar if it can be drawn in the plane without edges crossing. Without edges crossing means sometimes we can draw the graph like this. This is nothing but K3. You know very well. This is K3. Complete graph with 4 vertices. Complete graph with 4 vertices. K4. Each of degree 3. Here 2 edges are crossing. But the same graph we can draw like this also. So that it is a planar graph. How many plane we have? 1, 2, 3. Outside one, infinite plane, that is 4 we can consider. The same graph can be drawn like this, so that the graph is without any edge crossing. This is known as planar graph. When we consider K, 3, 3, complete bipartite graph. The same graph we cannot draw without any crossing of edges. If you try like that, we can try maximum. How many edges without crossing we can draw? I show you. None of the edges crossing. When you start with this one, I can start like this. Now also the edges are not crossing. But when I wish to draw this with these 3 vertices, I can make only one edge without crossing of another edges. One more thing also I can draw. But I cannot draw a edge by connecting these 2 vertices without crossing of any other edges. Therefore, K 3, 3 is non-planar. This is planar. You can draw it anyway, but what it is the possibility to, maximum possibility to draw the same graph without crossing of any 2 edges. Here it is possible. Here it is crossing. You can't say that this is non-planar. You have to try in some other way to draw the same graph without crossing of any other edges. If the possibility arises, you can say that is planar. If none of the way you can draw the same graph by means of without crossing 2 edges, then it is non-planar. This is surely non-planar. K3, 3 is non-planar. K4 is planar. You understood planar and non-planar? Hello? Hello? One of you reply, Jakruti. Jakruti. You understood planar, chromatic number, graph coloring. Coloring means we mean only the vertices. But when you study the 4-color theorem, we are coloring the planes. For example, the plane with we can have a graph like this. Wait. So how many colors we need to color the plane, not the vertices. We are not meaning with the vertex. Plane, here red color, here green color. The outside we can use it as blue color. This is known as infinite plane. This is a finite plane. Why? Because it is bounded by the edges. It is closed by edges. So there are 3 colors we need to color the planar. Likewise, you can color any critical complicated plane by means of maximum 4 colors. Anything you can consider, even our India map, when we consider like this, There are so many states we have. It is divided the map into the 32 states. So how can you color it? Only 4 colors maximum we need to color, distinguish the states. Only 4 colors we need maximum. Not only the world map, any plane you can consider, maximum we need only 4 different colors to map the plane. Any complicated, you can draw with any complicator. Maximum we need only 4 colors to color the map by distinguishing planes. That is known as 4-color theorem. Okay, we cannot use 5 minimum colors. I am talking about the minimum, cannot exceed the 4. Okay, here I draw one complicated graph. There are so many planes we have. We can start with red. If I color this plane by red, I cannot use this red color by its neighboring planes. So here the one vertex. So red I cannot use here, these all planes, and outside also. Okay, here I use blue. Once I use blue, I can use blue here. Once I use green, I can use green here. Red, blue, green, yellow. I use yellow here. I can use here red. Here it is. Again, what color I need? Red, yellow, red. Blue I used that. So here it is, I can use some other color. What it is?
Yellow.
Yellow. Here, what color I can use? Actually, the graph is not properly drawn. That's why we couldn't cover it. But when you draw it properly, definitely here one more plane is there. Here you mark it as yellow. Here you mark green. Here it comes as red. Likewise, you can color all the distinguished planes, distinguished subplanes by maximum 4 colors to cover the whole region. This is known as 4-color theorem. Is it clear? Is it clear? Hello? Hello?
Yes, ma'am.
Next, the chromatic number of Kn, any complete graph, we can, I draw K5. Here, we need n colors, n different colors to color the vertices. Why? Because when you consider your vertex, it is connected by remaining 4 vertices. So that I cannot use, suppose I started with red, I cannot use red again with these 4 vertices. Why? Because this vertex is connected by remaining 4. So I have to color the different colors: red, green, blue, yellow, violet. So every complete graph with n vertices needs n different colors to color the vertices. Okay, this is one I repeated university question. One more thing, when you have a tree needs always maximum 2 colors. Maximum 2 colors. Any tree you can draw. We need maximum 2 colors. Suppose I started here red. I have started here red. Then I have to mark blue, blue. Once I marked blue here, I can use red, red. Once I use the red, I can use blue here, I can mark it red. So alternatively, I can use the same two colors. So the tree, it needs only two different colors to color its vertices. Is it clear? These are all the things you should know about chromatic number and graph coloring. Now we can do some problem. Find the chromatic number of the following graphs. Find the chromatic number. Chromatic number, what it is the meaning of chromatic number? The minimum number of colors. What it is the minimum number of colors we need to color the given graph. That is known as chromatic number. For the following graph, we can find the chromatic number. Find chromatic number of the following graphs. First graph, this is G1, G2, chromatic number means we talk about the vertex coloring. Okay, when you study four color theorem, that time only we studied planar graph, plane coloring. Can we do the problems now? For the vertex A, I give red color. Then I cannot use this red to B, C, D. I can use B to blue color. Once I use the blue color here, I cannot use blue also, but I can use blue to D. I need one more different color for C. Why? Because C is connected by both red and blue color. Colors I use capital letter. Okay. F is connected by B, but not connected by red. So I can give to F red color. E, blue, red, green I can give. E, F, D, E, F, G, G, H, I, J, A, L, M, N, O. Can you fill the colors? G, already I used red here. E is not connected to G directly, so I can give G again. Once I fix it G here, I can use red and blue. I used blue here, I cannot use blue and green here, so I can use red. Red here, I can use green and blue. Then I can give to M, I cannot give red. Why? Because already I marked red here. I can use green. Red, blue. This is three chromatic. The graph G1 is three chromatic. Can you find the chromatic number of the second graph yourself? After finding it, tell me the answer. Hello. Can you tell me the chromatic number of the second graph, all of you? Prabhat Kumar. Prabhat Kumar. Hello. Shall I rub the board?
Okay, ma'am.
What about the second graph, chromatic number? It's also 3 chromatic. We need minimum 3 colors to color all the vertices of the second one. Now the question you write down. One second, sir. Hello. 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 I just draw some graphs. You check whether it can be drawn by without crossing of edges or not. First graph. Hello. Can you hear my voice? Hello.
Yes, ma'am.
Okay. First graph. Second graph. Third one. Now you check whether it is possible to draw this graph without crossing of edges. Yes, it's possible. Why? Because this edge, it can be drawn like this. Now it is planar only. Okay, what about the second thing? Can you try it in another way? To draw this one, I can make like this. So this is also planar. Is it clear? Is this clear? What about this one? When we mark 5 vertices like this, the adjacent vertices all are connected like this. One cycle is purely completed. We have to draw 4 more edges. When we try to mark them, these 2 edges we finish. What about these 2? They cannot connect without crossing of edges. The one edge, it is nowhere possible to draw it without crossing of some other edges. Therefore, it is not planar. You understood the meaning of planar graph? Hello? Shall I rub the board? Next question. Determine whether the given graph is planar or not. If so, draw it so that no edge cross. First graph is like this. A, B, C, D, E, F. Can you make it as a planar without crossing of any 2 edges? Can you try yourself? Tell me. You
Yes.
try and then tell me. Is it possible to draw without crossing of any 2 edges?
No, we are trying.
Yeah. Just try it. After that, tell me the answer, whether it is planar or non-planar. Two more edges we have to complete in that graph. Here one vertex. D, E, F, A, B, C. Have you tried it? Is it possible
Yes,
to draw
ma'am.
without crossing?
It is possible.
It's possible. How it's
Yes.
possible?
Ma'am, from B to F, we can draw the line inside
Okay.
and C to D from outside the triangle.
It's planar.
Yes, ma'am.
Okay. What about this graph? You tried and then tell me. We don't have vertex here. We have only 6 vertices. So try this. I take at 9. Is it possible to draw it as planar?
No, that is not possible, ma'am.
Why it's not possible?
Ma'am, one vertex will always stay. So if
AF and DC. We
yes, ma'am.
cannot draw them without crossing of edges. That's why it's non-planar. Students give attendance number 1,
Yes, ma'am.
2, number 2,
Ma'am, he's there, ma'am. He's facing some network issues, ma'am.
3,
3 present, ma'am. 3 present.
4. Okay. 4,
We have
Present,
network
ma'am.
issue.
4
4
percent,
present. Yo.
5,
Chat box, ma'am.
6, 7,
Present, ma'am.
8,
Present, ma'am.
9,
Present, ma'am.
10,
Present, ma'am.
13,
Chat box.
Chat box, ma'am.
okay, 14,
Chat
14,
box.
15,
Present, ma'am. Present, ma'am.
16, okay, 16,
Present, ma'am.
17,
Present, ma'am.
18, Sriram, 18, absent, 19,
Present, ma'am.
20, 20 absent, 21, absent, 22, absent, 23,
Present, ma'am.
25,
Yes, ma'am. Present, ma'am.
27,
Chat box, ma'am.
28,
Present,
28,
ma'am. Present, ma'am.
29, okay, 29, absent, 30,
Yes, ma'am.
30,
I'm 21 present, ma'am.
Yes, ma'am.
He wrote
30,
in
30
chat
present, ma'am.
box.
okay, 21%. What about 30? Naman Shiva.
In chat box, ma'am.
Chat
Yes,
box,
present,
ma'am.
ma'am.
Okay, 31,
Present, ma'am.
32, 32 absent, 33 absent, 34 absent, 35,
Present, ma'am. Present, ma'am.
36, Absented. 37. Absented. 38. Absented. 39.
Present, ma'am.
40. 40. Absented. 41.
Present, ma'am.
Ab-
Ma'am, 40 present,
42.
ma'am. Ma'am, 40 present.
Okay. 42.
Present, ma'am.
43.
Present, ma'am.
Okay. 44.
Present, ma'am.
45.
Present, ma'am.
46.
Present, ma'am.
47.
Present, ma'am.
48.
Present, ma'am.
49.
Present, ma'am.
50.
Present, ma'am.
51.
Present, ma'am.
52. Absent. 54. Absent. 56.
Present, ma'am.
Okay. Today absent is 18, 20, 29, 32, 33, 34, 36, 37, 38, 52, 54. 11 absentees.
Ma'am, 52 gave in chat box.
Okay. Okay, students, up to this, your topics all are over. You please go through with your PPT, other notes. Okay, you you can prepare for your exam in your textbook also. That is already posted. It's a soft copy in your classroom. Okay. Do you have any more doubt? You can ask me in the forthcoming classes. Tomorrow you have one more class. That time you can ask your doubts in 4th and 5th unit for your CT3 portion. Okay. Thank you, students. Now you can leave from the classroom. All of you can leave from the class.
Thank you, ma'am.